In this course, you will learn how to create a full-stack application using MongoDB for the database, Java and Spring Boot for the backend, and React for the front end. Farhan Hasin Chowdhury teaches the backend section of this course, and Gavin Lon teaches the front end section of the course. Both these instructors are very experienced and have created many popular courses. The project featured in this course is a great example of the creation of a separation of concerns between the client code and the server code. By implementing a loosely coupled architecture, these two parts, implemented using different technologies, can evolve in parallel and independently from one another. So let's start learning from Farhan.
Hello everyone, welcome to the Java with MongoDB course on the freeCodeCamp YouTube channel. I am Farhan Hasin Chowdhury, one of the instructors in this course, and I will teach you all about developing a backend API using Java, Spring Boot, and MongoDB. The other half of the course will be taught by Gavin Lon.
Hi, I'm Gavin Lon. I'm a full-stack developer and have over 20 years' experience working as a software developer. In this course, I'm going to be playing the role of a front-end developer, and my responsibility will be to demonstrate building a front end using React.js. The SPA application that we are going to create will use HTTP GET requests to appropriately retrieve data from a remote server through communicating with the relevant API's endpoints. And HTTP POST requests will also be made to the relevant endpoints to appropriately save data on the server side. Of course, our data will be stored within a MongoDB database on the relevant remote server.
So without further ado, let's jump in and start working on our API. In the beginning of the course, you will have to download two new softwares from the internet. The first one being Java Development Kit or JDK. If you already have JDK installed on your system, you should be good to go with that. But just in case you do not have it installed, I'd suggest you navigate to oracle.com/java/technologies/downloads. The link will be in description. Once you have landed on the download page for Java, you may find multiple versions of JDK available. As of the recording of this course, the latest version is Java 19 and the latest LTS version is Java 17. LTS stands for long-term support, and JDK 17 will receive updates until September 2024. JDK 19, on the other hand, will receive updates only until March 2023 and will be superseded by JDK 20. In many cases, when you are deploying a Java application on a production server, it's suggested that you use a LTS release for better stability. And for this course, I will stick to Java 17 since that's the latest LTS. Now, depending on when you are watching this course, there may be a new LTS release, so feel free to download and install that. So I'll switch to Java 17, and since I am on Windows, I will go to Windows and the 64-bit installer. As you can see, it's only 152.85 megabytes, and depending on your internet connection, it may take a few minutes to download. Once you have downloaded the installer, make sure you have installed it on your system like any other software you have done before. And since the installation is so straightforward, I will not spend a lot of time showing you the entire process. After you have finished installing JDK on your computer, open up your terminal window and write java c --version. And if you do not get any errors from this command, this is a positive sign, and as it says Java C 17.0.5, which indicates that I have successfully installed 17.0.5 version of the JDK. Now Java C is the short for Java compiler, which you may or may not have already guessed. Apart from this command, you can also use java --version to check the version of your Java runtime environment, and as you can see, it says 17.0.5 LTS, which means we are good to go. Since you have successfully installed the JDK on your computer, next up you will need a good code editor or IDE. When it comes to Java, there are plenty of options out there. You can go with Eclipse or maybe configure Visual Studio Code, but I would suggest that you go with IntelliJ IDEA. Now, the people at JetBrains are known for making really good IDEs, and when it comes to Java, IntelliJ IDEA is pretty much the industry standard. Although the ultimate version can cost you some money, there is also a free version available by the name of Community Edition. Now, to download IntelliJ IDEA, navigate to jetbrains.com/idea/download. Again, the link will be in description, and look for the Community Edition. This is the black download button here, and depending on your platform, i.e. Windows, macOS, or Linux, you may get a different format. For example, if you are on macOS, you will get a DMG image, and if you're on Linux, you will get a tar file. So I'm on Windows and I want to download the exe installer and not the zip one. So I'll select exe and then hit download. Now the IDE is a bit larger than the JDK in size, around at 649 megabytes. But again, depending on your internet connection, it may take a few minutes to download. Once you have downloaded the software, please go ahead and install it like any other software that you have done before. Congratulations on your getting the JDK and IntelliJ IDEA getting installed. Next up, you will need an account at MongoDB Atlas. Now, you may or may not already know that MongoDB Atlas is a platform from MongoDB themselves that allows you to spin up MongoDB servers on the cloud. So in order to use MongoDB Atlas, you will have to navigate to mongodb.com/atlas/database. Again, the link will be in description, and use the sign in button. Once in the sign in page, you can either use your Google or GitHub account to log in, or you can sign up with your other email addresses for a new account. Now, I already have an account on MongoDB Atlas, so I will just use those credentials to log into my account off screen. As you can see, I have successfully logged into my account, and for first time users, you may have to set up a new organization of sort. Just put any name as the organization name and you should be good to go. Since we are using these for just our development purposes, it's okay to just use any data that you have. So once you have set up your organization, you can create new projects. So I will hit the new project button here, and I'll have to give my project a name. Now, since we are creating an API that is related to movie, I'll just call mine movie API and hit next. I will just go ahead and create project since I don't have any other member to add. Excellent. Now we are inside our movie API project and we are ready to create a new database. So you can use the build a database button here to create a new MongoDB database on MongoDB Atlas. So just go ahead and click this button. And there are three different categories. There is serverless, there is dedicated, and there is shared. Now, for development purposes, a shared server should be fine and it's completely free. But if you're working on an application that has some user and have some real life usage, you may go with dedicated. Serverless is something else, and maybe we can talk about it in a different course some other day. So select shared and hit create. Okay, next up, they will ask you about which provider you want to use. I always go with AWS since AWS has a server on Mumbai, which is near Bangladesh and has the lowest ping for me. But if you like, you can go with Google Cloud or Azure. Now select whatever region is the nearest to you to make sure that you are getting the lowest amount of ping possible. Next, you can choose a tier. Again, for free usage, we will use the M0 sandbox tier. It will give us 512 megabytes of RAM, which is more than enough for our usage. We will have a very small amount of data, to be honest. And then Next up, there are additional settings. We don't have to touch them, and the cluster name. Now you can customize the cluster name if you wish, but I will just leave it as cluster 0 since I like it that way. Then hit create cluster. Okay, next up, you will have to create a new user for this cluster. You can also use an SSH certificate, but I will just go with the old and trusty username thing. So I will name my username Solid Snake since I'm a Metal Gear Solid fan, but you can name it anything you want. Now, when it comes to password, make sure you are always choosing a very strong password and not ones that are easy to remember. Use a password manager maybe, but always use hard to guess passwords. So I will just use the auto-generate secure password. And I will also make sure that I am copying my password to the clipboard since I will be needing this later on. Okay, then hit the create user button. Yeah, it shows Solid Snake and the password. And finally, you will have to set up some IP access list. So the way it works, once you have set up a new database, you will have to allow a set number of IP addresses that can access that server. Opening up a database server to the world is not a good idea security wise. So you should always use your current IP address here. But since this is just a course and we are using this database for development, I will open up this server for all the IP addresses out there. And to do that, you can write 0.0.0.0/0. And in the description, you can just write everywhere and hit add entry. So yeah, that's there. And then click on finish and close. Okay, they will congratulate you and whatnot. Hide quick start guide. Yes, go to database. Just close it. Excellent. Now we have a database up and running on MongoDB Atlas, and we can use this database, connect to it, read and write data from and to it, and use it just like a local database that you may have used in your computers. You see, MongoDB Atlas is a very beautiful service. I have used it for development as well as for production in the past, and I have never had any bad experiences with it. So next up, you can use some sort of database client to connect to this database, maybe something like MongoDB Compass. So you can go ahead and click on connect. And MongoDB will give you multiple options that you can choose from. So first up, you can connect to your database server using MongoDB shell. You can connect to the MongoDB server using your application that you are working on right now. You can connect to MongoDB server using MongoDB Compass, which is MongoDB's own graphical user interface for working with databases, and I will just show you that. Finally, you can also connect using VS Code. Now let's pick connect using MongoDB Compass for now. And I do not have MongoDB Compass on my computer. So I will pick Windows 64-bit. And I will just hit download Compass. Once you have downloaded and installed MongoDB Compass on your computer, you can start the software from your start menu or desktop. Once you start MongoDB Compass, it looks something like this, where they are giving you the option to connect to a new database by using this kind of URI. Now, where do you get this URI? If you come back to MongoDB Atlas, you will see that they are actually giving the URI right here. Just use this copy button to copy the entire URI and go back to MongoDB Compass. Now remove this localhost URI from here and paste it yours. Now, as you can see, it says MongoDB plus SRV, then your username followed by a colon, and then it's looking for a password, right? So what we are going to do, we will use the password that we created earlier and paste it in here. And then we'll leave everything as is. And we can say save and connect. You can name it anything. So I am naming it Movie API. You can change its color if you want to and say save and connect. Okay, so it took a few seconds, and as you can see, we have successfully connected to our Movie API cluster. Now, as you can see, there are two databases. One of them is called admin and the other one is called local. Now, we do not have to do anything with these. These come by default with all the clusters out there. So just leave them be, and we will create new databases very soon. To create a new database, you can always go and click this plus sign, and inside database name, let's put maybe what should it? Let's call it Movie API DB. And inside collection name, now if you are new to databases like MongoDB or document based database, you may or may not know that collections are like tables in case of relational database systems. So in something like MySQL or Oracle database system, you have databases, and inside those databases, you have tables. Now, in case of MongoDB and other non-relational databases, you have the database name first and then collections. For example, in our cases, we will have a collection of movies where we will save information about different movies. So we can say movies and hit create database. So as you can see, we have a new database sitting here, Movie API DB, and there is a collection called movies. So right now, there is no data at all. Now, in order to work with our API, it would be convenient if we have a bunch of data in our collections. And if you navigate to github.com/fhsinchy, which is my username, and /movies, you will get the entire code for this API already written. And inside that repository, you will see a folder that says _data. Now, inside this folder, there is a JSON file that you can use as a source of data for the collection we have just created. So I would suggest you go into this JSON file, then select raw, and then hit Ctrl S and save this JSON file somewhere on your computer. So once you have downloaded the file, you can then import it to your collection. To do so, come back to MongoDB Compass, and while you have the movies collection selected, you can click on this import data button or this add data button, then select import file, and our format is JSON, and we will select a file from our downloads and movies.json. And you can also take a stop on errors, then hit import. Wait a few moments, hit done, and voila, we have the information of 10 different movies on our database. So as you can see, each of this movie is a document, okay, as it says documents 10. So inside a collection, each of these movie are a single document. And what do we have inside these documents? Well, we have an ID. We have the IMDb ID for this title, Puss in Boots. We have the release date, which is a string. We have the link for a trailer on YouTube. Then we have an array of genres. So this particular movie belongs to 5 genres. Then we have a link to our poster. We have link to 10 backdrops that will be later utilized in the front-end application, as you will see. Finally, we have an empty array for review IDs. Now, this will come into play later on in this course, so just be patient with me for now. Okay, so one thing that I'd like to mention right here, I am using the tmdb.org API for these images. Now, TMDB is an excellent website and they provide a free to use API for developers as long as you are giving them credits where due. So I will be using their API for showing the images. So now that we have created a new database on MongoDB Atlas, we have set up a new collection, we have imported some data into it. It's time for us to start working on our API code. Now, the first step to writing our API using Spring Boot is to initialize it first. To do that, navigate to start.spring.io. Again, links will be in the description, and let's start initializing our project. First, we'll have to pick a programming language, which is going to Java in this case, but if you're familiar with Groovy or Kotlin, you may go with them. Then we will have to pick a project build automation tool, and the initializer supports both Gradle and Maven, which are two of the most popular build automation tool for Java. I am going with Maven simply because I have more experience working with this than Gradle. Next up, picking up the Spring Boot version. Now 3.0.1 is the latest stable version and we will be using that throughout the course, but if you'd like to try out some more bleeding edge features, you can use the snapshots once you have become more familiar with the framework. After that, we will have to fill up the project metadata. Now the group is usually written in reverse domain format. So for example, my website is farhan.dev and I would like to name my group dev.farhan. So if you do not have a domain of yourself, you can name it anything you like as long as that package group is not referring to someone else's project. Next up, the artifact name. The artifact name is simply the name of the project. So in this case, I will be putting movies in here, but feel free to call it something else if you feel like that. Next, there is a description field and you can put something like after that, we will have to pick a packaging format. Now, jar is a very popular packaging format for Java and it stands for Java Archive. WAR, on the other hand, stands for Web Archive, and you may think that, well, WAR is more suited for this project since it's going to be a web application, right? Maybe yes, but since jar is more widely used than WAR, I will be going with jar. Next, picking the Java version, obviously I'm going to pick 17 since we just spent quite some time setting up Java 17 on our computers. Once you are done with the left column, let's focus on the right column. In this one, you will have to pick the dependencies that you would like to use in your project. So use this add button and you will be presented with a very long list of dependencies. Now, the first one that we are going to use in our project is Lombok. It's an annotation library that saves you from writing a lot of boilerplate code. And you will see what I mean in action very soon. So please be patient. Since we are going to pick multiple dependencies, you'll have to keep pressing either Control on Windows or Linux and Command on Mac. In fact, it says here, right on the right corner, press Control to multiple adds. Okay, for multiple adds. So I'm pressing down on Control and I will pick Lombok. Lombok has been picked. Next up, Spring Web. And finally, let's see. No, not SQL. Under NoSQL, we will need Spring Data MongoDB. Yeah, that's pretty much it. You can also search for things here, for example, DevTools, and let's add that as well. Once done, you can exit out of this selector by pressing escape on your keyboard and have a look at the list of dependencies and make sure you have picked everything. Now, there are other dependencies that you may learn about later on, such as the reactive web or GraphQL or REST repositories or something like maybe Spring Security, which can be used for authentication and authorization. There is OAuth 2 client if you are into OAuth and things like that. But since we will not be getting into authentication and authorization in this course, we will stay away from them. Okay, once you are happy with the configuration in this initializer tool, go ahead and click Generate. It will take a few seconds to generate the zip archive and it will start downloading automatically. Once downloaded, you have to extract this movies.zip or whatever you have named your artifact.zip file to somewhere in your computer easily accessible. After you have extracted the downloaded zip file somewhere on your computer, you can go ahead and open it in your favorite IDE or code editor. In my case, it's IntelliJ IDEA and I have extracted my project on my D drive. So I will go ahead and click on open first. Then come to the folder where I have extracted the project and I will pick it up. Okay, so IntelliJ IDEA will ask whether you actually trust this project or not. This is a safety feature to save you from malicious code from running on your computer. So since we are writing it ourselves, I'll just pick trust project and give IDEA some time for resolving all the dependencies. And once it's ready, you are free to go. Let's try to understand the project structure first. So ignore the .mvn folder. It's managed by Maven, so we don't have to worry about it right now. There is the src folder, which is short for source, and it will contain your program source code as well as the test codes. We are not going to write any tests, so let's jump into the main folder. So inside main, there is Java and resources. We will have to work inside both of these directories. So let's go inside Java, and as you can see, here is the name of our project, dev.farhan.movies. It may be different in your computer, depends on what you have chosen in the initializer, but it should be something similar. Then there is a class that represents your application's name. So since I have named my artifact movies, it says movies application, which is pretty appropriate, to be honest. Now the movies application class contains around 10 lines of code minus the spaces in between. So let's try to understand what it's doing. Now the first line is actually declaring a package, which is pretty self-explanatory. Next, there are two import statements. The first one is a class called Spring Application. Now this particular class contains a method called run. And to start your Spring application, you actually have to call this run method and then pass your application class to it. And then you can also pass some command line arguments, which we are not going to touch. The second import statement imports the Spring Boot application annotation. So annotations in Java are usually used to let the compiler know about what this class does. So other than this class, there is more or less nothing inside this package. So let's try to run our application and see if we can have anything on our browser. Okay, so you can actually click on this play button besides the main method to run the program, or this class play button, or this play button at the top. Let's use this one. Okay, so if your IDE says Lombok requires enabled annotation processing, just go ahead and click on enable annotation processing and it should be fine. Now, if you look at the terminal, you will see that there is a nice art that says Spring, the Spring's version, and there is a bunch of logs, and there is an exception. The exception states that the application is failing to connect to any MongoDB database at all, which is true since we have not let the application know about our cluster, our username, our passwords, and things like that. The application cannot connect to our MongoDB database. Now, it's fine if you want to leave this error here, or if you want to get rid of this error, you can just first stop the application, open the pom.xml file, which contains a list of all the different dependencies that we are using, and then look for MongoDB. It should be here somewhere. Yeah, there you go. Dependency, artifact, Spring Boot, starter, data, MongoDB. So just highlight the entire thing and press Ctrl and then /, which will comment this out. Then right click on pom.xml and then go to Maven and go to reload project. Yeah. Now try to run the application once again. Yeah. No error whatsoever. So if you look at the logs, it will say that Tomcat started on port 8080. Tomcat is actually a web server that will serve as the web server, the development web server for our application. Now you will have to switch to your web browser to see the application in action. So let's do that. And then you can navigate to localhost 8080. There we go. Now it says white label error page. That's fine. At least we know that the application is booting up and we are actually hitting the API itself and not just some other page. Well, what this error states is that there is no endpoint at all. So although we have an API, there is no API to hit. I hope that makes sense. Now let's go back to our code and try to write our first endpoint. Now after where it says Spring Boot application, we will say REST controller. It's another annotation that lets the framework know that this class is actually a REST API controller and not just another class. Then inside this class, you will have to say get mapping. And next, we will have to create a new method called public, and the return type will be string. And the name of the method can be anything, but let's just call it API index for now, because this is the root endpoint, or let's call it API root. Yeah. And we can say return hello world. I know hello world programs are boring, but it's essential, you know. So this get mapping annotation, which what it does is that it lets the framework know that this method right here, API root, is a get endpoint. So if I put a bracket right here and then inside I'll say slash, just a /. Let's stop our application and run it again. Let's see if there are any errors. Looks fine to me. Let's switch to our web browser and do a refresh. As you can see, it says hello world. And let me just increase the zoom level a bit so you can, yeah, hello world. Now, instead of putting a forward slash here, if I say it for say /root, rerun the application, you will see that the white label error page is back. But if you navigate to /root, you will see hello world. I hope this makes sense. Although this is a valid endpoint, we are not going to make our API like this. We will actually divide our application into separate layers. There will be a service layer, there will be a data access layer, and there will be an API layer. So let's go forward and get rid of this code and start to put together our movies API. Now, in my opinion, the first logical step would be to configure the database for our application so that we can successfully connect to the MongoDB cluster that we have set up previously and talk to it. To do so, open up the src folder right here, go inside main, go inside resources, and open the file that says application.properties. Now, in this file, you will have to write the different application properties that is related to your project. Now, for example, right now we are trying to configure our MongoDB dependency. And to do that, you will have to write spring.data.mongodb.database equals to the name of the database. I hope you remember that we named our database something like movies API DB. So we will write movies API DB. And next, spring.data.mongodb.uri. Now, in here, you will have to actually write the URI to your MongoDB cluster like you did with Compass. I have my URI already copied to my clipboard, and I hope that you had saved it somewhere safe, like I said in the beginning of the course. So I'll just go ahead and paste it right there. And you can get rid of this /test thing and the last slash, and it should be fine. Okay, so our application should be able to connect to our database. Now to test it out, let's go back to pom.xml. Let's remove the comments. And then let's start our application and see, we have forgot to reload our project, and the IDE is actually suggested me to load the Maven changes. So I can just click this button, or you can go ahead and right click, then go to Maven and reload project. Let's use this button and see if it works fine or not. Of course it does. Let's run the application. And now the error is gone. And actually it says some things about the MongoDB driver cluster, and this is a positive sign. If it failed to connect to the database itself, it would have screamed at us and whatnot, but thankfully it's fine. Now, if you have worked with any applications, specifically web applications in the past, you may already know that putting sensitive data like this in a file that's going to be in your GitHub repository is not safe at all. Instead, what you should be doing is putting all these things in a .env file. So we can right click on resource, go to new, and create a .env file for ourselves. And we can write down a few properties here. Mongo database, then Mongo user, then Mongo password. Finally, Mongo cluster. Now you can go back to the properties file and you can start moving these values one by one to your env file. So this is going to be the Mongo database. Next up, the Mongo username, which is solid snake in my case. So I'll go to Mongo, then Mongo password. Finally, the cluster. And I sometimes like to put them inside quotes. This makes sure that if one of the passwords or username or clusters contains some special characters in them, it would not disturb the order of things. So I would like to put these quotation marks around each values. Okay, now we have our env file ready to go. What I would suggest that you create another env file simply called .env.example for later references. Nice. Then make sure you open up the .gitignore file, and as you can see, the Initialize project actually comes with a pretty good gitignore file already, but we will have to add a few things for ourselves, right? So you'll say, you can actually copy this thing from here and paste it and say env file. Yeah. And then you say .env. This will make sure that you do not accidentally commit the .env file into your repository and open up your database to the world. Now, the only problem with Spring is that Spring doesn't support reading .env files out of the box. So what we will need is we actually need to install a new dependency to our project. And I would like to take this opportunity to show you how you can add new dependencies to the project later on. So I'll switch back to my browser. I'll open up a new tab and I will search for Maven dependencies, something like that. Yeah, and here is Maven repository. Then let's search for something along the line spring.env. Yeah, I am referring to this one by Paul Suarez. I apologize if I have pronounced his name wrong. Let's select this one and we can see that it says Spring plugins 1.0 and it says central and whatnot. Okay, so the name of the thing is me.paul Suarez spring.env. So as you can guess, this is his group name and this is the name of the artifact or the project itself. So we can go back to our code. Let's open up pom.xml. And inside the dependencies part, make sure you are inside dependencies and not outside somewhere here. After the last dependency, we will create a new one. So it's a dependency and the ID helps us by auto-completing this. And we will say that the group ID is me.paul SCHWAR, just to make sure you can always copy it from here. No one's going to judge you for that. And then name of the artifact, which is spring.env. Now, it's not strictly necessary to define a version as well, but you can do so by saying version and then put maybe the latest one, 2.5.4, 5.4. Yeah. So that's it. Let's reload Maven. And yeah, now our project has the ability to use the spring.env artifact and read.env files. Let's go back to our application properties and replace these hard-coded values with our .env references. To do so, open up the resources and we'll need the env. So Mongo database, Mongo user, Mongo password. Okay. So you will first have to get rid of this value and then start with a $sign and curly braces. And inside the set of curly braces, you will see say env dot mongo, what did I call it? Database. Yeah, Mongo database. And you can kind of copy it from here. Then you'll replace solid snake by Mongo user. Excellent. Then this should be Mongo password. Password, right? Yes. And finally, the cluster. Mongo cluster, yes. What does this mean? Okay, we can ignore this typo, and every once in a while you can actually come to this problems tab and have a look at what's the ID is complaining about. So the unused property, let's just ignore them from now. Which one is, oh yeah. Okay, let's ignore this for now. And the typos, okay, Mongo is not a typo. Next up, let's try running our application once again and see if our env file has taken any effect or not. So as it turns out, our MongoDB connection is fine, which means the env file has been read successfully and we have successfully secured our confidential information from going out into the world. Now, you don't have to write everything inside a env file. You can actually use this env dot name of the variable notation to access any environment variable in your operating system. So I'll not get into that anymore since we don't need it. Let's go ahead and get along with our project. Now, in our application, there are two types of data that we are going to work with. First, there are the movies, and then there are the reviews. So we will need to first create two separate classes for representing these two entities in our application. So first, left click on your project name, new and Java class. Let's call it movie. And inside this movie, we will first have to annotate this class as a document. This will let the framework know that this class represents each document in the movies collection. And we will also define the name of the collection here, movies. Then inside here, we will have a bunch of private data. So private object ID, this will represent the ID of this movie. Then private IMDb ID, string IMDb ID, which will represent the IMDb ID of this movie. Then private string title, private string release date, private string trailer link. This will be a link to the YouTube page for the trailer. Private string poster, a link to the image on the internet. Private list string, this will be the genres because there can be multiple genres of a single movie, and this list class need to be imported. Java util. Finally, private list string, and This will be the backdrops. Now these backdrop images will actually be used in the front-end application, as you will see later. Let's just quickly jump to MongoDB Compass and make sure that we have indeed written all the necessary properties for this class. So as you can see, we have written ID, IMDb ID, title, yes, release date, trailer link, genres, poster, backdrops, and review IDs. Well, we will add review IDs a few moments later. Now, we'll have to also annotate this ID field as an actual ID. This will let the framework know that this property should be treated as the unique identifier for each movie inside the database. Okay, apart from this, we will also need getters, setters, and toString methods and some constructors. So instead of writing out getter, setters, toString for each of these private properties, we can just say @data, and this is one of the annotations that comes from the Lombok project, and it takes care of all those different getters, setters, and toString methods. Next, we will also add all args constructor. This is basically annotation for creating a constructor that takes all this private field as argument. Finally, no args constructor, which means another constructor that takes no parameters whatsoever. Okay, next let's create the reviews. So Java class review is the same deal. So this will be document and the collection name will be reviews. Now we haven't created this collection yet, but the application itself has the ability to create new collections, so we don't have to worry about that. We'll add data just like before, all args constructor, no args constructor, and then there will be two private properties. First one, private object ID. This will be the ID in this case, and then private review body, just body, string body. Okay, so as you may have already seen in the database design, that each of these movies has an array of this review, and we haven't yet added this array of reviews to the movie model yet. So to do that, we'll go back to the movie class, come near the end and say private list review IDs. Okay, so it matches this name, review IDs, and yeah, all the other names are matching as well. Yes. Now if you write it like this will be an embedded relationship, so all the reviews that are related to this movie will be added to this list of reviews. Now this is completely fine. In fact, if you are modeling a one-to-many relationship, such as one movie can have many reviews, this is the way to go. But since I'm trying to demonstrate some of the features of Spring Boot MongoDB data, I will show you a nifty annotation right here. So I will say document reference. So this will cause the database to store only the IDs of the review, and the reviews will be in a separate collection. So this is called manual reference relationship, and there are some other ways to create relationships in MongoDB. I would suggest that you search them up on Google or MongoDB's official documentation and read about them on your leisure. It will give you a lot of context. So now that we have our movie and review models ready to go, we can go ahead and start writing our controllers. So I will right click on my package, then a Java class. This will be called movie controller. And this is our first official REST API controller that we are writing in this API. Previously, we wrote a simple controller in our movies application class, but this time it's going to be a bit different. So first, we will need to annotate this class as a REST controller. And instead of mapping it to localhost 8080, I want to make it, mapping, request mapping. I want to make it map to /API/v1/movies. So any request to /API/v1/movies endpoint will be handled by this particular controller. Next, I will create a new get method. So I will say get mapping and then public. Let's return string for now. All movies. And then we can return all movies. Okay, let's try to run our program and see if it works or not. Let's hit the play button. Okay, it's compiled fine. Let's go back to our browser. And here, localhost 8080/root. We will get rid of root and say /API/v1/movies. And it works. Now, although it's okay to return strings from this endpoint, it's better to return a response entity. I'll show you why in a minute. So this is a generic type, so we'll say string. And then instead of returning all movies like this, we will say new response entity of type is string, and this is the value. Then http status.ok. http status.ok means 200. Let's rerun this program. Refresh, and it works just as expected. Now you may not see any difference here, but if you go back to your terminal and say curl I http localhost 8080/API/v1/movies, you will see we are indeed returning the 200 response code. This comes in handy when working on a front-end application, and any REST API out there should return proper status codes. Since we have the movie model right here, let's try to use it and pull some data from the database. For that, we will need a service class as well as a repository class. So let's create the repository first because that's the shorter one. So we'll say Java class, and we'll select interface because repositories are of type interface. And then we'll say movie in repository. Yeah. Now this interface will extend Mongo repository. This is the generic type, and we will have to let it know what type of data we are dealing with. So movie. And we'll also need to let it know what type of ID we are dealing with, which will be object ID. There you go. That's all for this interface. You will need to annotate this interface as a repository so the framework knows that this is a repository. And then let's create a service class, which will be movie service. This class will not extend anything. You will just need to annotate it as a service. Now inside this class, we will write the database access methods. So the first one will be public get all movies. But let's just name it all movies. And let's just change our controller method name to get all movies, because since it's a get mapping, we are saying get all movies. And the return type will be list of we will return a list of movie from this method. Now inside this service class, you will need a reference of the repository. To do that, you will say movie repository. It will be a private field and its name will be movie repository. Now, if you know Java, you may know that you will have to first initialize this bit of code. You will either have to initialize it using a constructor, or you can just use auto-wire annotation. What this will cause, it will let the framework know that we want the framework to instantiate this class here for us. Okay. Let's go inside the method now, and we will say return movie repository dot find all. Now this find all method is described inside the Mongo repository class. As you can see, it says right here find all, and it will return a list of the data type that we have passed right here. So a list of movie. So that's our service class right there. And then let's go back to our controller. We will need a reference to our service class. So we will say private movie service. And just like we did in the service class, we will auto-wire this service class since it has the service annotation right here. We'll say auto-wire. Excellent. And it's all set. Now inside the get all movies, instead of returning a response entity of type string, change it to list movie. So we are returning a response entity of type list movie. Then inside the method, we will have to write return movie service dot all movies. New response entity of type list movie, and inside movie service dot all movies comma http status dot ok. Yeah, let's take a look at our repository once again. Yeah, it's all set up. Service is fine, the controller is fine. Let's cross our finger and see if this works or not. We'll go back to our browser and hit refresh. Now the reason behind this problem lies in my env file. So as you can see, we have called our database movie API DB, but in our configuration, we mistakenly put an S right here. So we'll get rid of the S, restart the application, and hope for the best. And yeah, it works. As you can see, There are 10 movies in this list. Since it starts at 0 and ends at 9, there are 10 movies in this list, and the code is perfectly fine. Now let's go back to the code and let me reiterate on what we have done so far. So in REST APIs, usually there are multiple layers. So one of the layers is the API layer, which is this controller, and it will only concern itself about the task of getting a request from the user and returning a response and nothing else. And that's what it's doing. All it's doing is it's using a service class and delegating the task of fetching all the movies from the database and giving it back to the API layer. So it calls the all movies method inside the service, gets the list of the movie and returns them with HTTP status OK. It doesn't know what's going on inside the service class. Now, when we come back to the service class, this is where most of our business logic will go. For now, there is nothing to be worried about in these classes, but soon we will work with a little bit more complex business logics in this API. So this service class does is it uses the repository class and talks to the database, get the list of the movies and returns to the API layer. Finally, the repository layer is kind of the data access layer for our API. It does the job of actually talking to the database and getting the data back. I hope that makes sense. Now, since we have a list of all the movies in our databases, let's complicate it a bit more by trying to access a single movie. Now, we will begin by creating a new get mapping, and that is get mapping, and this will actually take an parameter, and we will have to say slash, then inside a pair of curly braces we will say ID. So we are trying to search a movie by its ID. So we can say public response entity. This time we will return a single movie, and we'll say get single movie. Sorry for the typo. We'll close the pair of parentheses and start our method. Now inside the pair of parentheses, we will have to say path variable, which lets the framework know that we will be passing the information we got in the mapping as a path variable, or we will be using the information passed in the path variable as a string or just object ID. So what this does is it lets the framework know that whatever we are getting through this path variable, we want to convert that to an object ID called ID. And then we can say return. Now first we will have to go back to our service layer and write a new method here. Public movie, single movie, and we'll say return movie repository dot find by ID, and we will get that ID right here, and it goes here ID. Save it, and this squiggly line, it says that return Java optional OK. So the thing here is that the find by ID method may not find any movie at all. Maybe the ID you have passed doesn't exist. So in those cases, it will have to return null. So we will have to let Java know that it may return null by saying optional movie. And we will just import the optional class. We will also have to fix our response entity movie. We'll say optional movie. Optional has been imported. Nice. And then we can say return new response entity optional movie, and inside there we can say movie service dot single movie. We will pass the ID that we have received, comma http status dot OK. Fine. Let's restart the application. Let's go to our MongoDB Compass inside the movie collection and copy one of the object IDs right here. Let's copy for Roald Dahl's Matilda the musical. Let's copy the object ID. Go back to our browser and you can say movies / and then the object ID. Okay, as you can see, we have found Roald Dahl's Matilda the musical. Now the problem is that I do not want to expose the object IDs of my collection entities to the public. Instead, what I want to do is use this IMDb ID to search for new movies. So let's see if we can find a way to do that. Now, although the repository comes with built-in methods for searching with ID, it doesn't come with methods for searching with IMDb ID. So what we will have to do is we will have to implement that method ourselves. And it's really easy because there is something called automatic queries that lets you form queries dynamically from property names. So we will say optional movie because it may return null once again. We'll have to import optional movie and we will call it find movie by IMDb ID, and it takes a string IMDb ID. Now, just by naming this method find movie by IMDb ID, MongoDB data, Spring Data MongoDB will understand what we are trying to do. It's that much intelligent. So now we can go back to our service class. We are no longer getting an object ID, but we are getting a string IMDb ID. And instead of find by ID, we will say find movie by IMDb ID, IMDb ID. And that's it. Let's go back to controller. We'll change this from ID to IMDb ID. By the way, you do not have to name the ID, IMDb ID exactly in this method. It's just that I know what I am doing in a later date. So we will replace object ID by string IMDb ID and then response entity optional movie. Yeah, this is fine. Yeah, IMDb. So technically this should do our job. Let's check it out. It seems like there has been a mistake. Okay, let's go up. looks like there's a problem. Let's go back to our movie repository. And the mistake is it should be IMDb and not IMBD. So as you can see, the framework is clever enough to see that I have misspelled the property name right here. So let's run the program once again and see if it runs or not. Find movie, I cannot find. Oh yeah, I have to correct it here as well. Yeah, and yeah, it should be fine now. Let's go back to our browser, and as you can see, API/v1/movies, and then I have used the IMDb ID for this movie. Hit enter and it works just fine. We can use the IMDb ID to search for movies now. Now you can actually form dynamic queries like this using any property name in your model class, as long as they're unique. Because if that's not unique, you will get multiple movies with the same ID or same name. Okay. Now that we have our movie controller sorted out, let's start working on our review controller, where we will let the user send us review and we will add those under a movie name. So let's first create a new repository, review repository, and it extends MongoDB Mongo repository, and the type will be review, and object ID is our type of ID. Yeah, that's there. Next, let's create a new service class. Oh, I almost forget to annotate this as repository. Let's create a new class called review service, and this will be a service class, so I will go service. Here I will say public, then this method will create a new review, so it will return a new review, then create review by create review. Then this method will take two parameters. The first one will be a string, which will be the review body, and the second one will be string IMDb ID. So what we are trying to do here, we will first look for the movie with the given IMDb ID, and then we will create a new review and associate that review with the found movie. So let's first create a new review. Review equals to new review. Now you may remember that in the review class we have an all-args constructor and a no-args constructor, but since IDs are auto-generated, we cannot pass an ID to this class. So what we will do, we will also generate a custom constructor that takes only the body. Now in IntelliJ IDEA, you can right-click inside a class, go to generate, and then constructor. And we only need the body part of this class. So that's there. Now let's go back to our service class and new review, and we will pass the review body. Excellent. Now that we have a new review, we will have to associate these to one of the movies. Now that we have a new review object, we will have to insert it to the database. And for that, we will need a reference to our review repository. So review repository, and it needs to be auto-var. Fine, and we will say review repository dot insert and review. Excellent, that's the review taken care of. Now we will have to associate with this with one of the movies, right? To do that, we will need a few things. Now the first thing that we need is called a template. To create a template, we will say private Mongo template. Now, you have already learned about repositories as one of the ways to talk to the database. The other way is using a template. You see, there are times when a repository just doesn't cut it. Maybe you have an operation so complex that it cannot be implemented within a repository, or even if you can implement it within a repository, it will be not suitable. So what we need a template. You can use this template to form up a new dynamic query and do the job inside the database without using the repository. So we will auto-var this. And then down here, we will say Mongo template dot update, since it's an update operation, and we will need to say which class do we want to update. So we want to update one of the movies, and then come to the second line and put a dot here. And then as you can see, there are multiple operations that we can perform. So we want the matching. Now inside the matching operation, we will need a new criteria. So we'll say criteria dot where, and inside where we will say IMDb ID. Make sure it's matching up with the column name or the property name inside the database. Then dot is the IMDb ID that we have got. Then come to the next line and put a dot once again, and then we will say apply. We'll say new update. This is called an update definition dot push review IDs, and then dot value review. So yeah, that's pretty much it. Okay. So what we are doing is we are using the template to perform an update call on the movie class, because I hope that you remember that each movie in our collection contains an empty array of review IDs. So what we need to do is we need to update this array and push a new review ID into this. So we are saying movie.class. Then we have to perform the matching. So which movie are we updating? We are updating a movie where the IMDb ID of the movie in the database matches the IMDb ID that we have received from the user. Okay. Then we want to apply this update. To do so, we call apply, and then we create a new update definition which does the job of making the change inside the database. So we say update.push review IDs. So we want to update the review IDs in this found movie, and the value of this movie will be review. So the review that we have just created, it will be pushed inside the review IDs array. Okay. Now, finally, we'll have to say dot first to make sure that we are getting a single movie and we are updating that. Now, one thing that I have done, which I shouldn't have, is we cannot new up a review like this. Rather, what we need to do is we will just save the review on insert, because when you call insert, it actually returns the data you just pushed inside your database. Okay, here first. Finally, we can return the review we just created. So let's review the create review method. We are taking a new Mongo template. We are using it to update the movie with the new review we just pushed using the repository. So like I said, sometimes you will have to code up complex business logics by yourself. And as you grow as a software engineer and a web developer, you will start to understand all these things all by yourself. So let's go back to our review service. Our review class is fine, review repositories, review service. Yeah. Now let's create a new review controller. And inside this controller, we will have only one post method. Now you may think, why only a single post method? How are we going to get all these reviews that are associated with a movie? I'll show you how. Now let's begin by annotating it as a REST controller. And then, of course, we will have to input the request mapping, which is /API/v1/movies. Yeah, movies. Okay, since the review form will be inside a movie's details page or in the page where you are viewing a single movie. So we can make the request to the movies endpoint instead of creating a new reviews endpoint. Now, when it comes to creating endpoints like this, it really depends on the developer's preferences. You may choose to organize your API differently from what I am doing here, and in a real life project I will do something different, but since it's just for learning and we are just getting started, I think it's fine. Inside the controller we will first need our service, so we'll say private review service, and we will auto add this. Nice. Then we will create a new post mapping. And then a new method, public, will again return a response entity, and this will be of type review. And we will call it create review method. Now inside this pair of parentheses, we will say request body, then map string, comma string, and we will call it payload. So we'll import map. So what we are saying to the framework here, that whatever we get as the request body, we would like to convert it to a map of the key string and value string, and we want to name this map as payload. You will see why this is. Then we will say return new response entity, And yeah, we can say review, obviously review. And then we will say service, review service dot create review, and we will pass two things. First one, payload dot get is the review body, and the second one would be payload dot get IMDb ID. Okay. Finally, we say comma http status dot created. It will be 201. Since we are creating a new review, we want to send 201 instead of the plain 200 because this means created and that means okay. So now that we have the post mapping done, we need a REST client, a separate REST client to test out our code. But before that, I can see that there is this quickly line under my review controller. So I will just go to problems and see what's wrong. Cannot resolve symbol IMDb ID. Okay, let's see where I missed the typo. Yeah, so it should be inside a pair of quotation mark and that's gone. See, this is the beauty of IntelliJ IDEA. It helps you a lot. Now let's restart our program and I will use Postman to test out our API. In fact, I just thought instead of mapping the reviews request to API/v1/movies, let's just go with reviews because that sounds more appropriate. Now let's start our application. And let's jump to Postman. So inside Postman, first I will create a new collection and I'll call it Movies API. Then let's create a new GET request, get all movies. So it will be localhost 8080/API/v1/movies. So it works out just fine. Let's copy the IMDb ID from one of these movies so that we can test out our next request, which will be get a single movie. And we should be able to carry everything from the previous request. Localhost /v1/movies/ then the IMDb ID. Let's execute and yeah, it works just fine. Finally, let's try to create a new review. Create a new review. And we'll say v1/reviews. Okay, that's I set the request by mistake, so it has to be post. Now inside body, I will say raw data in JSON format. So I will say review body will be I really enjoyed the movie with my family. Yeah. And then I will say IMDb ID colon and the IMDb ID. Now you have to make sure that the name or the key in this JSON data, review body and IMDb ID, exactly matches the two keys inside the payload, which is review body and IMDb ID. So what will happen is this endpoint will receive a JSON data from the user and then convert it to a map where the keys are a string and the values are a string. Then from this map, we will be able to access the review body, which is a string, and the IMDb ID, which is another string. And then through the service layer, we can create a new review on the database, update the movie to be associated with that review, and then return the review. And of course, there's a repository that works as the intermediary layer between the service class and the database. Let's come back to Postman and let's see if it actually works or not. Yes, so we have got 201 created. So theoretically, we should have created a new review for the movie Puss in Boots. Now let's go back to get a single movie. Hit send. Come down to review IDs, and of course, we have the new review associated with this movie. Now that's how we can get the list of review IDs. They will be embedded with the data of the movie they're referred to. So in terms of the API, that's it. I know it's a pretty simple API, but the goal of this course, or the first half of this course, was to give you some idea about how you can create a new backend API powered by Spring Boot and MongoDB. I hope that you have understood the basic concepts around using MongoDB and Spring Boot together. You can go ahead and further your study by learning about how to implement authorization and authentication. You can also learn about more complex relationships and maybe try to build a bigger API with deletes and puts and other kind of requests. I will be leaving the stage right now, and from now on, Gavin Lon will teach you how you can create a React application that can go with this API. So take care. I will maybe see you in another course in the future.
Now that you've learned how to develop the backend, Gavin will teach you how to develop the front end using React.
Just a quick note before we get started. This will not be a deep dive into React. My only goal here is to demonstrate how we can interface with a remote API from a front-end application created using React, through which we are able to retrieve data from a MongoDB database hosted on a remote server, as well as post data to our MongoDB database. Now, any data that we retrieve from the server will be in JSON format. JSON formatted data may be pleasing to some people, but most users of our application, I think, would much prefer something like this. So we are going to transform the data passed to us in a JSON format into an aesthetically pleasing front-end display. React and associated technologies provide an efficient way to create both aesthetically pleasing front ends, as well as help us developers to facilitate a great UX, user experience. I'd like to give a shout out to the MovieDB.org. All the movie poster images and backdrop images that we are going to use in the React application that we are going to build in this course come from the MovieDB.org. Right, let's get into it. Let's start by launching VS Code. And let's create a working folder on our local machines. I'm going to name my folder Movie Client. Let's open our working folder like this from within VS Code. So we are going to use the create-react-app command to generate our React project's infrastructure. You, of course, must have Node.js, preferably the latest version, installed on your local machine as a prerequisite before creating a React application. If you don't have Node.js installed, you can navigate to this URL to install the latest release of Node.js. So, from within VS Code, let's launch the terminal window so that we can create our React project infrastructure using the create-react-app command. You can launch the terminal window from within VS Code by pressing Ctrl and the tilde character. Great! So the current directory reflected at the terminal prompt should be the working directory that we have just created. My working directory is named Movie Client. Then at the terminal prompt, let's type in npx space create-react-app followed by the name we'd like to call our React project. So I'm going to name my React project movie-gold-v1. Then let's press the Enter key, and the create-react-app command generates the React project infrastructure, which includes all the relevant node modules that contain components that we are able to import into our React application. This process can take a while to complete. And we can see the process on my local machine has now completed. So at this stage, we don't really need the movie client folder opened within VS Code. We only want the folder containing the files for our React project. So at the terminal, let's use the cd command and then enter the name of the React application that we created using create-react-app. So I'm going to type cd space movie-gold-v1 and press the Enter key. So once we have made the folder containing the files for our React project's infrastructure, we can launch another instance of VS Code by typing in code space dot and then pressing the Enter key. This command opens another instance of VS Code where we are now directly within the folder that contains the files for our React project's infrastructure. We can now close down the first instance of VS Code because we only need the instance that we have just launched. So we are almost ready to create our React application. We won't be using some of the files that the create-react-app command generated for us, so let's delete the following files from within the src directory. Let's delete the setup-tests.js file, the report-vitals.js file, and the app.test.js file. We must also delete a setting from within the package.json file, which is to do with linting. We don't need this linting setting in our project. Let's save our changes. Lastly, let's open the index.js file and remove the code related to the report web vitals functionality, like this. Let's save our changes. And let's move on to installing a few npm packages that contain components that we are going to integrate into our application. If your project terminal is not available within VS Code at the moment, you are able to launch the terminal by pressing Ctrl and the tilde character. The next package we are going to install is Axios. Axios will make it easy for us to make HTTP requests from our React client to the relevant API hosted on a distant remote machine, so that we can retrieve relevant movie data from the MongoDB database also hosted on the relevant distant remote machine through HTTP GET requests. We will also be able to add movie reviews to the relevant MongoDB database through the use of HTTP POST requests, which will be facilitated on our React client through the use of Axios. We'll implement this functionality later in this video. So to install Axios, we can type this command at the command prompt: npm space install space Axios. And let's press the Enter key. Great! So let's install our next npm package, which will enable us to use Bootstrap for layout and styling purposes from within our React project. So let's type the following at our command prompts: npm space install space Bootstrap. Note that in order to integrate Bootstrap into our project, we must include this import statement within the index.js file. Let's save our changes. The next npm package that we must install allows us to use Bootstrap-related components for layout and styling purposes. So let's install React-Bootstrap for this purpose. We can install React-Bootstrap by typing npm -i React-Bootstrap. And of course, follow this by pressing the Enter key. Great! The next npm package that we are going to install enables us to easily install Font Awesome icons within our React application. The first Font Awesome related package can be installed by typing in npm -i @fort-awesome /react-font awesome. So make sure you type @fort-awesome here and not @font-awesome, which I know is a little bit confusing. So it's @fort-awesome -react- and then font awesome. Great. Let's install the second Font Awesome related package by typing in npm -i @fortawesome /free-solid-svg-icons. And let's of course press the Enter key. Excellent. To play movie trailers from within our application, we're going to use the React Player component. So let's install the appropriate npm package so that we can integrate React Player into our React application. So let's type npm -i React-player and press the Enter key. Great. In order to declare the paths where our components will reside in order to map the routes to our components, as it were, we are going to use relevant components from the React-router-dom npm package. So in order to install the React-router-dom npm package, let's type in this command: npm -i React-router-dom, and of course press the Enter key. Great. On our home page, we want to display relevant movies in a carousel. We can easily implement a carousel using Material UI. So in order to do this, we must install 3 Material UI npm packages. So we can install the relevant 3 npm packages by typing the following: npm -install @mui /material @emotion /react @emotion /styles. And let's press the Enter key. Excellent. In order to use the Material UI Carousel component, let's install the Material UI Carousel npm package. We can do this by typing in npm -install react-material -ui-carousel and press the Enter key. Great. And we have now installed all the NPM packages we need in order to integrate the functionality we want to include within our React application. Excellent! Let's get started with writing the code for our React application. So the first thing I'd like to do is set up Axios. So to do this, let's create a folder within the src folder. And let's name our folder API. Let's create a file within the API folder named axiosconfig.js. We can import Axios into our project with this line of code. So we can configure and export the Axios object that we'll use to make HTTP requests to the relevant remote API through this code. Note the settings that have been included here. We have the base URL setting, which provides the base address of the API endpoints that our client React application will be calling. So you'll see later on, when we use Axios to call an endpoint, we won't need to repeat the base URL with each HTTP request within our code. We'll only need to include the additional path information required to target a specific endpoint. If this isn't clear at the moment, it will become clear when we write code to make a HTTP request to the relevant remote endpoint. This setting here is necessary because during the development phase, the technology that the remote machine is using to expose the relevant API endpoints is called ngrok. I won't go into the specifics of ngrok, but we need to include this setting in order for our client HTTP requests to not be blocked by CORS. I won't go into the details of CORS, but it stands for Cross-Origin Resource Sharing. So all we need to know is that because the relevant web API is running in a different domain or origin, that CORS may block our access to the endpoint. The server code has included settings in order to overcome the restrictions imposed by CORS, and we are including this setting in the HTTP headers of our requests from the client so that we can overcome the restrictions imposed by CORS, i.e., so that we are able to access the resources made available through the relevant API endpoints. Great, so we have now set up Axios. Let's open the app.js file and write code to call an endpoint that will return an array of movie data. Let's write code to import our Axios object from within our axiosconfig.js file. Let's import the useState hook and the useEffect hook from React. Let's return a destructured array from the useState hook. The first item in the destructured array is named movies and will store an array of movie data returned from a call to the relevant API endpoint. The second item in the array is a function that can be used to change the state of the movie's variable. When the state of the variable tracked by React through the useState hook is changed, the component is re-rendered by React. So in this case, the app component will be re-rendered when the state of the movies variable changes. Let's create a function that will handle a HTTP GET request to an endpoint that returns an array of movie data. Once the movie data is successfully returned, this code that changes the state of the movies array is executed. You can see here we are passing the additional path information to the get method. This path information is appended to the base URL setting that we created when setting up the configuration for Axios. We are using async await for asynchronous thread management functionality on the client. I won't go into detail explaining async await and promises, but this functionality can be effective in ensuring that the UI is not blocked when potentially long-running operations, like for example a remote API call, are processed. The UI thread will not be blocked, and therefore the user screen will not, for example, freeze. The user screen will still be responsive, while a potentially long-running I/O-bound operation is processing. Once the relevant task has completed, the code directly below the code that kicks off the awaited process will be executed. So, it's like a promise is made to return to the appropriate line of code once the task, potentially long-running I/O-bound task, for example, has completed. As explained, this async await functionality is useful in order to ensure a better UX, user experience. In case something goes wrong during the execution of our HTTP request, let's wrap the relevant code in a try-catch block, and let's include code in the catch block to log the relevant exception to the browser console window. So you could be more thorough here in your code and check the HTTP status code. For example, if the HTTP status code returned from the server is 200, this indicates that the operation performed on the server was successful. I'm not going to include this functionality in this course in order to keep the code fairly basic for our HTTP requests that we are executing from the client. Let's implement the use effect hook so that the getMovies function is executed when the app component first loads. Let's also write code to log the results returned from the call to the relevant endpoint to the browser console window. Let's use the npm start command to run our React application. Let's look at the browser console window to see if our results have been returned from the server. Excellent! Our HTTP GET request made through the use of Axios executed successfully. So, the next step is to start implementing our routing functionality or routing functionality. Let's create a React component named layout.js. Let's open the layout.js file and import the outlet component from the React Router DOM npm package. To generate boilerplate code for our layout component, we can type RAFCE and press the tab key, like this. Let's rather use semantic HTML here and include main tags instead of div tags. Within our main tags, let's include a reference to the outlet component. Let's go back to the app.js file and write code to import the layout component that we have just created. Right. So I'm going to create a components folder within the src folder and move the layout.js file into the components folder. let's write the code to import the layout component into the app component. Let's write code to import the routes component and the route component from the React router DOM npm package. In the return part of the app component, i.e. where JSX code is returned from our component, let's write code to establish the route mappings, as it were, for our application's React components. So let's first add the routes element here. Within the routes element, let's include a parent route element. It's a parent root element because child root elements will be included within this parent root element, like, for example, a child root component that points to the home component. We'll write the home component in a bit. Will be a child of the parent root component that points to the layout component. So the layout component, referenced through the outlet element in the layout.js file, denotes the components pointed to by the child root component references that we'll include within the parent root element here. We'll include the relevant child root elements as we progress with the development of our React application. The next step is to open the index.js file and write code to import the browser router component, the routes component, and the route component into the index component. Let's include code to establish the relevant route mapping for the app component. Great! Let's create our home component. Let's first create a folder within the components folder named home. Let's ensure that the first letter in our home folder name is lowercase. Let's add a file named home with an uppercase H to our home folder. Let's type in RAFCE followed by pressing the tab key to generate boilerplate code for the home component. Let's simply type in the text welcome so that we can test our root functionality. We'll create the code for our home component in just a bit. Let's create the code for the root element that points to our home component within the app.js file. Oops, I can see a little bug in our code. This reference to layout is not correctly formed. Let's include the layout element properly within our code here. Let's type in npm start at our command prompts and press enter to launch the application. Great! So, let's create a component that will be a child component of the home component. We'll name this component Hero. This component denotes the Hero section of our home page that will display items in a carousel that are representative of movies to the users of this application. So let's create a folder within the Components folder named Hero. Within the Hero folder, let's add a file named hero.js. Let's also add a file to the hero folder named hero.css, where we'll of course include CSS code for our hero component. Let's write code to import the hero.css file into our hero component. Let's import the Carousel component from the relevant material UI npm package. Let's import the paper component from the relevant material UI npm package. Let's write code to destructure the props passed into this component. Only one destructured value containing an array of movie data needs to be included here. Let's implement the carousel functionality. Let's include the carousel element like this. Within the carousel element, let's write code to map each item in the movies array to an item displayed in the carousel. The paper element encapsulates each movie item displayed in the carousel. Let's include div tags so that the movie poster is displayed as well as the movie title is displayed for each carousel item. As you can see, I've included CSS class references in the relevant div tags. We'll style our components in the hero.css file in a bit, where we'll implement the appropriate CSS properties for these CSS classes. Oops, let's make sure that we are importing the hero.css class correctly here. Let's open the home.js file and include the hero element in the part of the code that is returned as JSX code from the home component. Let's make sure that we are importing the hero component into our home component. Let's write code to ensure that the movies array is being passed down from the app component to the home component and subsequently the hero component. And that's great. We are displaying the relevant data from the JSON data returned from the relevant API's endpoint, but let's customize the styling of our carousel through CSS code. We can position our VS Code editors to a pane on the left side of our screens, and we can position our browsers to a pane on the right side of our screens like this. In this way, we can watch the effects of our CSS code changes in real time. I'm not going to go into a lot of detail regarding the CSS code. The code will be available on GitHub, where you can examine it in more detail if you'd like. Let's first update the CSS code in the app.css file. This CSS code affects all components that are child components of the app component. And you are able to observe the effects of the CSS code on the browser in real time as the CSS code evolves. So let's import the Quicksand font from Google with this line of code. Let's set up the box sizing and font family properties for all elements. Let's set the body element's padding and margin properties to 0. Let's style the app class. Note that all of our components are children of the app component. Let's remove this code from the index.css file because it is not needed. Let's style the carousel component that has been implemented within our hero component. So let's include our CSS code in the hero.css file. And we are able to watch the effects on the carousel displayed in our browsers in real time as the relevant CSS code evolves. And we don't actually want the poster image to take up the carousel display as it is at the moment. We want an appropriate backdrop image, a larger image, to fill the background for each item in the carousel. I want to include a gradient that fades from dark to light from the bottom of each carousel item to where the title is displayed. In order to dynamically reference the background image URL for each carousel card, I'm going to use a CSS custom variable. So we can do this by including an inline style within the div element that references the movie-card CSS class, and within that inline style, assign a variable to the property that we wish to reference within the relevant CSS file. So here, we are naming our custom CSS variable img. We are setting the CSS URL value to the CSS background-image CSS property from the backdrops property of each movie in the movies array returned from the server. Note that the backdrops property returned from the server is an array containing paths to movie backdrop images. In this code, I'm choosing to reference the first backdrop image path in the backdrops array returned from the server. Each backdrop points to an image that we want displayed as a background image appropriately for each movie item in the carousel. We can now reference each background image from within our CSS class and style the background appropriately. So we are assigning the background-image CSS property a gradient that fades from light to dark. This is just a stylistic choice for our front-end display. You can see here in our CSS code how we are using the --img custom CSS variable to link the URL property value referenced in the JSX code in the hero component to the background-image CSS property in the hero.css file. You can see that the poster image is looking distorted, so let's style the poster and the title appropriately. Great, and we have used absolute positioning and the CSS flexbox to style our poster and handle where it appears in the layout. Let's style the title appropriately. Great. And our carousel is looking pretty good. Let's create the component to house our navigation display. Let's create the header component. So let's create a folder within the components folder named header. Let's create a file within the header folder named header.js. Let's import the appropriate font awesome components. Let's import the appropriate Bootstrap components. And let's use React Bootstrap components to create a responsive layout for our navigation menu, which will be displayed at the top of the screen. This is one of the huge advantages of using Bootstrap. It can save us a lot of time in creating responsive layouts. We are using the FA Video Flash Font Awesome icon for our logo that will be displayed in the top left corner of our screen within the navigation bar that we are creating within the header component. The login and registration buttons are being included here superficially. They are purely cosmetic, indicating that we could extend the functionality of this application to include login and registration functionality at a later stage. For example, if we wanted to enable users to create their own list of favorite movies or a watch list. The watch list link here is also there purely for cosmetic reasons. We won't implement a watch list component in this course. So, above the roots functionality, within the app.js file, let's reference the header component. Let's go back to the header.js file and make sure that our imports are correct. Let's run the code. Excellent. Our navigation bar and our logo looks pretty good. The next step is we want to be able for a user to click a play button icon on each carousel item and for an appropriate movie trailer to play. We'll enlist the help of the React Player component for this purpose. Let's first create a folder named Trailer within the Components folder. Let's create a file named trailer.js within the Trailer folder. Let's also create a file named trailer.css within the Trailer folder. Let's create the relevant import code in the trailer.js file. Let's import the useParams hook into our code from the React Router DOM npm package. A YouTube video ID will be passed into this component as a parameter. So we are going to use the useParams hook to extract the relevant parameter value from the relevant URL. The relevant parameter will contain a YouTube video ID, which will allow us to play a YouTube video, which is a trailer of the relevant movie, to the user. Let's import the React Player component. Let's import the trailer.css file. Let's create the boilerplate code for our trailer component by typing in RAFCE and pressing the Tab key. Let's create a div container in which our React Player component will reside. Let's assign the passed-in parameter value to a const named key. Then we can include the React Player component appropriately, like this. We want the player to include controls, so here we can set the controls property to true. We can set the playing property to true so that the relevant video plays as soon as the trailer component loads. And lastly, and most importantly, we can set the URL property to the relevant video on YouTube. So we can append the relevant YouTube video ID stored in the key const to the base YouTube address to point React Player to the YouTube video that will be played within React Player. Great! Let's go to the app.js file and include the relevant root information for the trailer component. Notice how we are able to let React Router DOM know, as it were, about the YouTube video ID parameter that our code within the trailer component must access. Let's include a play button icon provided by Font Awesome within our carousel. Okay, so the play button icon is present, but it needs to be appropriately styled, as it is tiny at the moment. Let's go to the hero.css file and style the play button icon appropriately. Great! Let's include a media query so that our carousel adapts to smaller screens. Great! Let's go to the trailer.css file and create CSS code so that the React player takes up 90% of the viewport height. Lastly, we need to create the link so when the play button icon is clicked, that the trailer component is invoked and the appropriate parameter is passed through to the trailer component. So the trailer link property retrieved from the server contains the entire URL to the YouTube video. We only want to pass the ID of the YouTube video to the trailer component from the hero component. We can extract the YouTube video ID by using the JavaScript substring method to extract the last 11 characters from the trailer link property, like this. Let's run the code. Excellent! The last component we need to create is the reviews component. The reviews component will enable users to view reviews from other users as well as add reviews for movies into the system, i.e., which entails a HTTP post request being made from our React component to the relevant remote API endpoint carrying the review data entered by the user, and the server-side Java code will then save the review data appropriately to the MongoDB database. Firstly, let's create a component named Review Form. This component will contain a form component that contains a text area control where the user can enter text that denotes a movie review. A submit button will also be included so that the user can click this button in order to submit the user's movie review. So let's create a folder named Review Form. Let's create a file named reviewform.js within the Review Form folder. Let's include the code for the functionality we have just discussed. Let's create the reviews component that will be a parent component of the review form child component. Let's create a folder named reviews. Let's include a file within the reviews folder named reviews.js. Let's include the appropriate import code at the top of the reviews.js file. Let's generate the appropriate boilerplate code for the reviews React component by typing in RAFCE and then pressing the Tab key. Let's use the useRef hook to reference the text area control within the review form. Let's use the useParams hook so that we can extract the movie ID parameter value from the relevant URL. This movie ID is actually the IMDb ID of the movie that we have retrieved through the API call that is made to retrieve the array of movie data from the server. The IMDb ID value, of course, is used to uniquely identify a specific movie. So when our component first loads, we want to call a method that is passed in as a prop to our component in order to retrieve the appropriate data for the relevant movie that the user wishes to review. So we can use the useEffect hook like this for this purpose. Let's use React Bootstrap components, for example, the row and col components, to create an appropriate layout for the reviews component. We want to display the poster for the relevant movie in the left part of the screen and the reviews in the right part of the screen. We can use the row and col components appropriately to achieve this. Let's include the review form element here, like this. Let's create a method named addReview and create the relevant HTTP POST request functionality for adding a review to the MongoDB database, which resides on a remote server. And let's write code to update the state of the reviews array on the client side optimistically, meaning that we are not using data returned from the server, i.e. data that is saved to the database, for updating the state of the reviews array. We are updating the array directly from the data entered on the client. We also want to include code that clears the relevant text area control once the user has successfully submitted a review. We are updating the state of the reviews array on the client through the use of the setReviews method that will be passed as a prop from the app component. Let's go to the app.js file and create a method that uses Axios to make a GET request for data pertaining to a single movie. So an IMDb ID value will be passed into this method to the movie ID parameter, and a HTTP GET request using the movie ID value appropriately in the URL will be made to retrieve data for a single movie from the remote server. So let's set the state for the movie variable. And to make our code clearer, let's extract the reviews array from the movie data and track the state of the reviews array. Let's make sure that the appropriate props are being passed down to the reviews component. We are now able to create reviews for the movies retrieved from the remote server, ultimately from a MongoDB database that stores our movie data. So we are adding reviews to our MongoDB database through an appropriate HTTP post request to an appropriate endpoint. Excellent! One thing we must do whenever we implement a list of uniquely identifiable items in our JSX code like this, is appropriately include the key property for each list item. To uniquely identify each item in the carousel, we can set the key property for each movie item displayed within the carousel to the appropriate IMDb ID value for each movie. This value has been passed down to us with the movie data array that we retrieved from the remote server using the appropriate HTTP GET request. I hope you've enjoyed building this front end using React, and I hope you feel that you have benefited from this course. If you've got to the end of this course, you've done exceptionally well. Thank you, and take care.